Hello students, welcome to the series of mathematical expectation. This is the part 2 of the topic mathematical expectation. In the previous video I discussed few definitions of expectation, and today also I will continue this topic, but here I will start with some properties of mathematical expectation. So the heading here is properties of mathematical expectation. Properties of mathematical expectation. So here, if I am talking about first property, expectation of ax plus b is a into expectation of x plus b. I will prove it here, where capital X is any random variable. Capital X is any random variable. So how we can prove this particular statement? So as we know, expectation of x can be written as minus infinite to infinite x into fx dx, where this fx is associated probability density function. What if I will convert this x into ax plus b? So it would be minus infinite to infinite, and this is associated as ax plus b into fx dx. As we know, integration is distributed for this particular summation term. So it is a minus infinite to infinite x fx dx plus b into minus infinite to infinite of fx dx. This term is what? This is just expectation of x as per this formula, and this term is what? This is the total probability. So here what I can write now, I can just write it like expectation of ax plus b is a into expectation of x, b into 1. It means expectation of ax plus b is a into expectation of x plus b. So this is, students, our first formula, which I have proved here. So there are some deductions as well, some, I will say, deductions from this particular formula. If I am considering here a equal to 0, so what I will be getting? Expectation of b is just b. It means expectation of any constant, expectation of any constant is the same constant, and if I am considering here b equal to 0, so I will be getting expectation of ax is a into expectation of x. This is our next formula. But here if I am taking a equal to 1 as well as b equal to 1, so our consideration is expectation of x plus b is expectation of x plus b. B is 1 here, so it would be expectation of x plus 1, and here also I will make change. So let me write it again. So for a and b both, it is expectation, it is just expectation of x plus 1, it is just like expectation of x plus 1 is expectation of x plus 1 only. So this is all about some properties of this expectation. Now I would like to discuss few examples from this mathematical expectation topic, and thereafter few more things I will be discussing. Now suppose this one question, this is related to mathematical expectation. Suppose one distribution, I mean to say probability distribution is provided. X is here taking values 4, 5, 6, 7, 8 and 9, and probability of x at small x is given as 1 by 12, 1 by 12, and thereafter it is 1 by 4, and then again 1 by 4, and thereafter it is 1 by 6 and 1 by 6. And one function is given here, f of x is 2x minus 1. 2x minus 1. So what is the aim here? Aim here is to evaluate expectation of f of x. So I mean to say we have to evaluate expectation of 2x minus 1. So I am going to solve this particular question. So how? Expectation of x, we know it is basically, basic formula I am writing, summation x, x into associated PMF. Now here x is having, if I will just place here x by 2x minus 1, it is expectation of 2x minus 1, and is summation x, this will be converted into 2x minus 1 into f of x. So what I can write here, as we can see, x is having the values from 4 to 9. So this summation will be from x equal to 4 to x equal to 9. So we can expand this particular summation. How? So first term is 2 into 4 minus 1 into f of 4 plus 2 into 5 minus 1 into f of 5 plus 2 into 6 minus 1 into f of 6 plus 2 into 7 minus 1 into f7 plus 2 into 8 minus 1 into f8 plus 2 into 9 minus 1 of f9. So what it would be? 2 into 4 minus 1 we can easily dealt with. f4 is what? f4 is just, as we know, this probability x equal to x is f of small x. So this is what? This is f4, this is f5, this is f6, this is f7, this is f8, and this is f9. So now this question is very easy. We can easily evaluate all these terms, 2 into 6 minus 1, this, and this, and thereafter all these values, f4 and then f5 and then f6 and thereafter f7, f8 and f of 9 we can take from this table, okay, as this, and rest of the 3 terms we can utilize here. So thereafter calculation is very easy. Easily we can determine this particular required term, like x squared by 3 between the limit minus 1 to 2, and it is 0 elsewhere. It is 0 elsewhere, and any the function g of x is given by 4x plus 3. And what is our aim here? Our aim here is to find expectation of g of x. I mean to say expectation of 4x plus 3. So as we know, this is from the continuous data. Interval is provided here. So this is an example for continuous random variable. So how we can answer this particular question? Expectation of x, as we know, for continuous random variable minus infinite to infinite is x fx dx, where this fx is what? It is the associated probability density function. So what we will do now, this capital X will be replaced by 4x plus 3. So it is expectation of 4x plus 3 is minus infinite to infinite. This would be 4x plus 3, this one small, and into fx dx. So we can see the range here. We can check the range here for random variable, that is minus 1 to 2. So this limit will be changed, minus 1 to 2, 4x plus 3 into x square by 3 dx. Now this is not a big deal here. We have to just solve the single integration. When actually you will solve this particular single integration, easily this answer can be obtained, and this answer will be equal to 8, which can be verified later on by all of you. So students, you can easily evaluate this single integration and your final answer will be like this. Now, thereafter, few more important aspects of mathematical expectation I would like to discuss. So what are those aspects? Let me describe here. So one formula is like expectation of summation of joint functions. It is equal to expectation of g of xy plus minus expectation of h of xy. It is like this one, where gxy is depending upon two variables, hxy is also depending upon two variables, but I want to prove this particular statement. How I can prove it? I will just prove it by the formula. As we know, all of us know that expectation of gxy plus minus h of xy, how I can write it? In continuous form, we can write it minus infinite to infinite, minus infinite to infinite. This will be written as g of xy in small plus minus h of xy in small, associated fxy dx dy. So I mean to say this is joint probability density function, and this double integration is distributive, so we can easily distribute it like minus infinite to infinite, minus infinite to infinite, gxy fxy dx dy, and then plus minus minus infinite to infinite, and double integration here, and hxy into fxy dx dy. So what we can obtain here? As we know that this particular term I'm talking about, it is just expectation of gxy, and plus minus this particular term I'm talking about is expectation of h. This is just like g of yes, it is just like h of x comma y. So it is expectation of g xy and plus minus h of x y. It is like this one, gxy, expectation of gxy plus minus hxy. Similarly, if in this particular topic I will consider, let us consider that gxy is only a function of x. We can consider it, that is not a problem, g of x, and h of xy is only function of y. Then how this formula will be transformed? It will be expectation of g of x plus minus h of y is expectation of g of x plus minus expectation of h of y. It is like this one. So one more deduction I want to discuss here. Suppose in this previous formula, I am talking about this formula, I am considering g of x is capital X and h of y is capital Y. So one more deduction we will be getting, that is expectation of x plus minus y is expectation of x plus minus expectation of y. So here from two formulas can be extracted, like expectation of x plus y is expectation of x plus expectation of y, and expectation of x minus y is expectation of x minus expectation of y. So I would like to tell one name here of theorem, that is addition theorem. That is addition theorem of what? Addition theorem of expectation. Addition theorem of expectation. So it is what? If x and y are two, these are two random variables, if these are two random variables, so expectation of x plus y is known as expectation of x plus expectation of y. It's like this one. Thereafter, there is one more theorem I want to mention here, that is known as the multiplication theorem of what? Multiplication theorem of expectation. But in this approach, in this particular theorem, the random variables are independent. These are two independent random variables. These are two independent random variables. So how expectation of x into y is defined? That is expectation of x into expectation of y. So this is known as the multiplication theorem of expectation. So it is all about this. So students, in this particular video, I have discussed few properties of expectation, and thereafter I have told you that how to evaluate the expectation in discrete and continuous approaches, and thereafter few more theorems on expectation I have discussed.